it looks like this. Or it can look like this. Yeah, now I gotta check. You've never talked about these before, is that correct?
Wait, is it always off center?
No, it doesn't have to be off center.
Isn't it usually like?
It could be right in the middle,
Yeah.
okay? But they can be anywhere. They look like kind of a U, right? So you have talked about these, or no, this is the first time you've ever seen them?
Parabolas?
Parabolas. Okay? They have these parts. They have branches.
Right now, page.
These are the branches right here. They have things called a vertex. And the vertex is either the highest or lowest point. So the vertex is right here on this parabola. The vertex is right here on this parabola. We call this vertex the minimum because it's the lowest point. We call this vertex the maximum because it's the highest point. We also have something called the line of symmetry. And the line of symmetry goes right through the middle of the parabola. So here are examples of where the line of symmetry is. Where else, what specific point does the line of symmetry always pass? Through the vertex, correct? It will always, always do that. That's huge. The next thing that sometimes we have are these things that are, there's three names that you'll see quite often that mean exactly the same. They're called roots. Sometimes they're called solutions. And sometimes they are called zeros. They mean the same thing. Yes?
Is this still under parabola?
This is still under parabola.
Okay.
Yes?
If it goes like sideways.
It's not a function, is it?
Okay.
Okay. So ours will always look like this. Okay. When we get to calculus, we get to talk about them when they're sideways. Okay, because we talk about everything in calculus. All right. Now, this parabola has two solutions, or two roots, or two zeros. Why? Yes, ma'am. It crosses the x-axis twice. That's why there are two of them. Now here's my other question. Why do I write sometimes they have roots, solutions, or zeros? Why isn't it always two? Sophia, can you give me an example? The first one right here. This has none. That one has no solutions because it's not touching the x-axis.
Okay.
This vertex right here is as low it's going to go, right? Because these branches mean it's going to keep going up forever. It's not going to turn around and head back. Is there another drawing that can tell you how many possible solutions there may be? We have 0, we have 2, is it possible to have 1? Morgan.
Would it be if the parabola was just touching the x-axis at 0?
Yeah, what is touching the x-axis?
The vertex.
The vertex, right? So this is kind of what Sarah was talking about. That's quite a common right here. Here it's 1. Can you have 3? No, because these branches aren't going to turn around, are they? So you can either have 0, you can have 1, or you can have 2. Yes, sir.
Can you have like a sideways parabola?
Sam, can I have a sideways parabola?
No, because it's not a function.
Correct. Now, we do talk about sideways parabolas in calculus, right, Sam?
You talk about everything.
Right? We talk about everything in calculus. Okay? But right now, we're only talking about functions.
Oh, sorry.
Right? Now, the expression for a quadratic is this. ax squared plus bx plus c. These are called coefficients. They're called coefficients because they're multiplying the variable. This a is called the x squared coefficient. The b is called the x coefficient. C is not a coefficient because it's not multiplying a variable. We call that a constant because it's always going to be a number. Now, Lydia, suppose I have nothing there. You don't see a constant. It's blank. Guess what the constant is?
0.
It's the most dangerous number out there. So 0 would be the constant. The equation looks like this. Y equals ax squared plus bx plus c. I just make it equal to y. The function. Does anybody know what the function looks like? What function form is? It looks like this. F of x, perfect, equals ax squared plus bx plus c. That means when I plug a number in for x, I'm going to square it, and we'll finish this tomorrow. Okay?